PDE. Okay. I've said this topic, this issue at the first session. At this term. در جلسه اول کلاس من اینو به شما گفتم. یک فرم کلی معادلات با مشتقات جزئی مرتبه دوم هستش. Is a general form of the second order PDEs. At this general form of PDEs, when B2 minus 4AC is smaller than 0, the equation is called elliptic. When B2 minus 4AC equal to 0, the equation is called parabolic. And when B2 minus 4AC bigger than 0, this PDE is called hyperbolic. Okay? For this session, we are going to study parabolic equation, diffusion equation, and advection diffusion equation are classified as parabolic type PDEs. The general form of diffusion equation is UT equal to KUXX. Okay, UT equal to KUXX is the general form of the diffusion equation. Are you sure this equation is parabolic? Yes or no? آیا این معادله پارابولیک هست؟ Yes or no? Please check it. Please check this equation is parabolic or no. Or answer to me. A at this equation is, B at this equation is, and C at this equation. What the value of A at this equation? What is the value of A at this equation? It is a C.
Equal
A
K.
is the coefficient of round 2 over round x2. Okay. What the value of A at this equation is K. Okay.
K. Yes.
Is K. What is the value of B at this equation? B is the coefficient of round 2 over round x round y. At this equation, we don't have U around U over round x and U around U over round y. And then B is 0. And what about C? Please see. C is the coefficient of round 2 over round y2 or round 2 over round t2. At this equation, we don't have UTT, and then C equal to 0. Okay? And when we compute B2, please see, we compute B2 minus 4AC. When we compute B2 minus 4AC, the result is B is 0 and C is 0, and the result is 0. And then this equation is parabolic because B2 minus 4AC is 0. Thus, the result is diffusion equation is classified as a parabolic type PDE. Diffusion equation can be used to model the time-dependent temperature distribution along a heated in one-dimension bar or heat conduction. برای معادله انتقال حرارت استفاده میشه. Heat conduction means انتقال حرارت. And mass diffusion is some applicable of diffusion equation. One of the more important application of diffusion equation is heat conduction. Okay? And another PDE that is classified as a parabolic type PDE is the advection diffusion equation. Advection diffusion equation has the general form as ut plus cux equal to kuxx. At this PDE again, A is J and B is the coefficient of round 2 over round x round y, and B is again is 0, and C is a coefficient of round 2 TT, and don't have round 2 TT, and then C again is 0, and again we have B2 minus 4AC equal to 0, and then this equation is also a parabolic equation. Advection diffusion equation may be used to model transport of a pollutant in a river. What about coefficient K and C? The coefficient K, C, and K in the above PDE are the quantified properties, are the parameter of the model. C and K are the parameter of the model, and this value, these coefficients are determined experimentally. منظورم اینه که این C و K بچه ضرایبی هستن که هر مدلی که شما حالا در دنیای واقعی بخواین حلش کنی، خانم زینب من میگم برای بچه‌ها این توضیح رو بدین، حالا چون شما برای کار پارامترتون هر مدلی که انتخاب کنین پارامتر داره. کلا مدل های واقعی، مثلا مدل سرطان، مدل HIV، مدل کرونا، هر مدل که شما تو زمینه حالا مهندسی باشه، پی باشه، هر زمینه که شما یک مدل ریاضی داشته باشید، این مدل پارامتر داره. الان تو این مدلی که میگیم مثلا برای انتقال حرارت داریم K و C داره. خب هر مدل یک سری پارامتر داره. حالا این پارامترها از کجا میاد؟ به شکل تجربی اینا به دست آورده میشن. یعنی یک سری محاسبات روی داده‌های واقعی انجام میشه. این ذرایع برای هر مدلی به دست میاد و مدل با مدل هم که ما کار میکنیم این پارامترها متفاوت میشن. خانم زینب خودتون متوجه شدید من چی گفتم؟
اوکی خانم واقعا.
یه بار دیگه میخوایم بگم متوجه شدین؟ اینا پارامترهای مدل هستن. هر مدلی شما اصلا کلا کار ما آنالیز چیه؟ ما میایم واقعی رو مدل ریاضیش میکنیم، حلش میکنیم. حالا مسئله ممکنه مسئله نفت باشه، مسئله گاز باشه، مسئله سرطان باشه، مسئله کرونا باشه، HIV باشه. هر مدلی ما چیکار میکنیم؟ هر مسئله واقعی رو ما مدل ریاضیش میکنیم، بعد به روش‌های تقریبی حلش میکنیم. این کار ما انزلادی.
أساتذة وياي، هسه هذا الموضوع اللي تسولف بصورة عامة عالية اللي راح نستفاد من عنده أكثر شيء يستفادون بالهندسة والحرارة، هي بصورة عامة عن الحرارة دا يحكي، يعني الحرارة البارامتر اللي موجودة بالفيزياء. أوكي، تقول المعاملات اللي راح استفاد من عندهن، استفاد عندهن مثلا احتمال بهاي شغلات مال تحليلات الكورونا، وشغلات مثلا قالت مال ذني ما الصيدلة اللي موجودات بالتحاليل. المهم ذني الموضوع اللي راح تستفاد من عندهن. يقول أول شيء قبل ما يستفادون من عندهن يعني يستخدموهن بالأجهزة مال الطبية، يجون يعملون عليها حسابات اللي احنا راح نحسبهن بالرياضيات. نستفاد هذا الموضوع كله بذني السوالف. يعني راح نبدي بالرياضيات ويحولوهن للكيمياء، للفيزياء، للأجهزة الطبية. بس بصورة عامة أتوقع هذا الموضوع كله عن الحرارة دا يحكي، وبالهندسة هم. Okay.
So at this advection diffusion equation, C and K are the model parameters, and this coefficient are determined experimentally. Okay. In the at the heated bar, K would be the coefficient of thermal conductivity, ضریب هدایت گرمایی. K in the heated bar is a coefficient for thermal conductivity. Or in the when we say C in the advection diffusion equation, C is a wave speed. C can be a wave speed in the fluid flow. For the fluid flow model, when we use advection diffusion equation, C can be a wave speed. Okay? And today, we are trying to make a finite difference method for diffusion equation. Suppose that the diffusion equation with the initial and boundary condition as follows. Ut equal to Kuxx is a diffusion equation, and our goal is to try to introduce to you some finite difference method for numerical solution of diffusion equation. بحث امروز ما اینه که بیایم برای معادله دیفیوژن یک سری روش‌های عددی بگیم. Ut is equal Kuxx. The domain of this problem for x starts from P until Q and T bigger than T0. Be careful. If you have remember, for elliptic equation, the region of the problem should be closed, and we should have the value of boundary problem in the left, right, top, and in the first stage. Okay, for elliptic equation, we need 4 boundary conditions and initial conditions. Okay, but for diffusion equation, we don't need to the top condition for the top of domain, and we need only 3 boundary and initial condition. So, do you understand? برای مسائل بیزایی بر الپتیک ها که ما جلسه قبل گفتیم باید 4 تا مرز داشته باشیم. مرز و حالا مقدار اولیه. ولی برای مسائل دیفیوژن، برای دیفیوژن اکویژن ها ما دیگه 4 تا مرز لازم نداریم. فقط ما 2 تا مرز و یک مقدار اولیه لازم داریم. We need the initial condition. This line is for initial condition. And we need boundary condition for the left, and also we need a boundary condition for the right. Okay, so for diffusion equation we need 3 boundary and initial condition. Ux and T0 equal f of x, the initial conditions, because this is the value of u at t equal t0. For all of x start from p to q. The value of u at the initial time, at the first step, determined by using f of x. The second is a boundary condition. This equation says u of p and t equal to g of t. U of p and t, p is the left or start point of x, and means u, p and t, all of the point on the left boundary. For all of u, for all of point at the left boundary, we should use the g of t at every time for the left boundary. At this left boundary, the value of x for all of point is p. The left boundary, the value of x is p, and for all of point on this boundary, we use gt for the value of u. And similarly for the right boundary, on the right boundary, the value of x is q. X equal to q. And for all of the point, we can use the value of h for you on the right boundary. اوکی؟ خانم زینب من اینو میگم برای بچه توضیح بدیم. برای مسائل دیفیوژن ما دیگه مرز بالا نمیخواد داشته باشیم مثل مسائل به الکتریک ها. یه مقدار اولیه داریم مثل F، یه مرز چپ داریم، یه مرز راست داریم. روی مرز چپ همه جا ایکسامون P هست، نقطه شروع ایکسامون هستش و مقدار یو روی این مرز از GT استفاده میشه. روی مرز راست ایکسمون همه جا Q هستش و از تابع HT برای مقادیر یو روی مرز راست استفاده میشه. خودتون متوجه شدین؟
بله خانم واقعا. بذار بگم تقول هذا موضوعنا مال اليوم. كنا ناخذ ذنيك نقاط شبكة كنا نستفاد من عندهن. هنا كنا نقاط الشبكة كان عندنا لازم 4 حدود بالنسبة لنا. كان عندنا يعني من النقاط لازم من 4 جهات موجودات يعني كان حتى يكون لنا شبكة. هسه هنا تقول ليش مو شرط بين يكون عندنا 4، احتمال راح يكون عندنا بس 2، احتمال راح يكون عندنا 3. هسه هنا شو تقول لنا؟ تقول لنا لازم عندنا نقاط حدودية من جهة اليسار اللي هي x نفسها P، ومن جهة اليمين اللي هي x نفسها Q، والدالة اللي استفاد من عندها من جهة اليسار هي G للT، يعني هاي ثابتة أتوقع، واللي من جهة اليمين H للT بدلالة الزمن، والتحت دائما راح تكون F بدلالة X. أوكي؟ أوكي خلاص.
Okay, I continue. At this lecture, I introduce to you 3 finite difference methods for diffusion equation. First, explicit method. Second, implicit method. And 3, Crank-Nicolson method. Okay? Excuse me. For some minutes, I close my speaker, my microphone. Excuse me, everybody. Excuse me. I continue. I said I introduced to you 3 finite difference method for diffusion equation. 1 explicit method, implicit method, and Crank-Nicolson method. We start by implicit method. Do you know implicit method? Not for PDE. شما روش‌های صریح می‌دونید چه روش‌هایی هستن؟ تو ODE باید خونده باشید. تو ODE باید خونده باشید explicit method. خانم زینب توی درس ODE explicit ها رو خوندید یا نخوندید؟
نه کنم خوندیم خانم اولین بار می‌بینم.
روش هیون، روش فرزند، مثلا روش رانگ کوتا روش ایمپلیسیته. اوکی؟ مثلا روش اویلر هم
اویلر هم گرفتین درست.
اویلر هم ایمپلیسیت داره هم اکسپلیسیت داره، یعنی هم صریح داره هم ضمنی. اینا رو خوندی؟
نمیدونم، یاد ندارم. اون باقی
مگه شما اودیتون رو تمرین نمی‌کنی درستون رو؟
نه.
یعنی چی نه؟
یعنی استادشون یعنی مثل شما نیستن، فرق میکنن، فقط درس میدن و همش صحبت میکنن تموم میکنن، همین. یعنی نمیدونم نخوندیم هنوز.
بخونید بچه، اودی خیلی مهمه. یعنی پی دی مهم، هم اودی هم پی دی. یعنی اودی رو اگه بلد باشین خیلی کمکتون میکنه. هرچند حالا اودی راحت
هست، استادش خود فرق میکنه اصلا، یعنی فقط خودش صحبت میکنه همین، ما اصلا بفهمیم نفهمیم اصلا سوال نمیکنه، نه تمرین میده نه چیز میده، هیچ نمیده. یعنی اصلا نخوندیم هم اصلا، یعنی اصلا خودمونم تو خونه نخوندیم هیچ کدوممون.
اونم شبیهتون بخونید دچار مشکل میشه. بخونید پلیز. استادی هارد ODE. ODE is very important. PD is more important. اوکی. ببین بچه، حالا من اینو میگم خانم زینب، بچه‌ها بگین تو هر درسی، حالا ODE یا PD. خب وقتی میگیم روش اکسپلیسیت، یعنی روشی که سریع تو هر گام زمانی که هستیم از روی گام‌های زمانی قبلی مثلا اون رو حل کنیم. این بهش میگیم اکسپلیسیت. میخواد ODE باشه، میخواد PDE باشه، فرقی نمیکنه. وقتی میگیم اکسپلیسیت متد، یعنی ما تو هر گام زمانی که وایسی، مثلا فرض کنید حالا چه ODE چه PD، پلیز اتنشن، وقتی ما تو هر گام زمانی هستیم، مثلا این گام زمانی هستم، گام زمانی j به اضافه 1، میتونم از روی مقادیر گام‌های زمانی قبلش بیام مقادیرم رو در گام زمانی فعلی حساب کنم. این میشه اکسپلیسیت، صریحه. ولی ضمنی اینجوری نیست که من بتونم بیام از روی گام‌های زمانی قبلی مقدار حالا اون مجهولاتم رو در گام زمانی فعلی حساب کنم. باید همه‌شو با هم دیگه بنویسم، به دستگاه میرسم حلش میکنم. این فرق اکسپلیسیت و ایمپلیسیت هستش. خودتون متوجه مثلا نگاه کن توی تابع میگیم y مساویه با fx is، حالا من یه بار خودم توضیح میدم اگه بچه متوجه نشدن چون بهشون به عربی بگیم. اوکی. when we have y equal to f of x, this function is explicit function. Okay, is an explicit function. But when we say f of x and y equal to 0, it is an implicit because we don't have y based on the f of x, and we don't have y explicitly from x. Okay, we have x and y together. We have x and y together as a function of two independent variables. وقتی میگیم تابع صریح y مساوی هست با fx، یعنی ما صریحاً y رو بر حسب x داریم، ولی وقتی میگیم fx و y مساوی با 0، این تابع ضمنیه، یعنی ما y رو بر حسب x نداریم. یه عبارت داریم هم بر حسب x هم بر حسب.
متوجه شدم.
لطفاً بهشون توضیح بدید.
تقول عندنا نظريتين بالنسبة للدالة of الx، امبليكس وام، هاي مكتوب اولا وثانيا، الاولا بالاحمر والثانيا بالاحمر. اوكي، تقول عندنا دالتين، الاشتقاق مالتهم مش وقت راح يكون هاي اشتقاق مالتهم اشتقاق اعتيادي او اشتقاق ضمني. اذا كانت الواي بدلالة f of الx، هاي راح تكون اشتقاق صريح، يعني اشتقاق اعتيادي. اذا كان الدالة f of الx مو مباشرة y تساوي، راح تكون إذا كان f بدلالة x و y يجب أن يكون يساوي 0، راح يكون عندنا اشتقاق بالنسبة إلها اشتقاق ضمني. أوكي. وبعد شغلة قالت مادة هذا الدكتور هذا اللي ياخذنا بالODE، قالت هذا الموضوع كلش مهم ولازم تعوفوه لأن تستفادون عده، هذا على مود تحلون هنا وهناك، اثنين المهمات. أوكي.
As I said to you, the first method is explicit method. For construct an explicit method for diffusion equation, we use the forward finite difference approximation for U, T, and use a symmetric finite difference for UXX. Means I've approximated UT at I and J by using UI and J plus 1 minus UI and J over delta T plus O of delta T. Delta T is the order of truncation error. For UXX at XI and YJ or UXX at I and J, we have UI plus 1 and J minus 2 UI and J plus UI minus 1 and J over delta X2 plus O of delta X2. Or delta X2 is the order of truncation error. Okay? Thus, we use forward finite difference for UT and symmetric finite difference for UXX. When we replace these two approximations in the diffusion equation, we have UI and J plus 1 minus UI and J over delta T equal to K UI plus 1 and J minus 2 UI and J plus UI minus 1 and J over delta X2. This explicit solution to diffusion equation has a O of T accurate in time and O of delta X2 accurate in space. And then truncation error for the PDE is O of delta T plus O of delta X2. O of delta T is the order of accuracy for derivative for time, and O of delta X2 is the order of accuracy for UXX or second derivative for space. When we rearrange this equation and when we rearrange so that the unknown value put on the left hand and the known value put on the right hand, we have UI and J plus 1 equal to K delta T over delta X2 UI minus 1 and J plus 1 minus 2 K delta T over delta X2 UI and J plus K delta T over delta X2 UI plus 1 and J. Please attention. We have obtained this equation by rearranging this equation. At this equation, I mark by a star. At this equation, when we have the indexes I and J plus 1 or J plus 1 in the unknown value, because when we are at the Tj, the value of U at Tj is none, and the value of U at the next step size means Tj plus 1 is unknown. Okay, we are at the Tj, the value of Tu at Tj is known, but the value of U at Tj plus 1 is unknown. And when we separate the known value and unknown value, we have this equation. Okay, خانم زینب، این معادله‌ای که ما با جایگذاری به دست آوردیم، اونهایی که اندیس دومشون جی به اضافه یکه تو گام زمانی بعدی هستن، ما مقادیرشون رو نداریم، ولی اونهایی که اندیسشون جی هست در گام زمانی فعلی هستن که ما مقادیر یوشون رو داریم. اوکی؟ اینو لطفاً برای بچه‌ها بگید. خودتون متوجه چی گفتم؟
بله متوجه شدم خانم.
ما تو گام زمانی تی جی میخوایم از گام زمان تی جی بریم گام زمانی بعدی.
بله.
توضیح بدید لطفا براش.
تقول احنا عندنا زمان الوقت هو التي الزمن. زين تقول عندنا زمن تي وعندنا تي زائد واحد. اقول جي تي للجي وتي للجي زائد واحد. تقول هذا القانون راح اعوض بمكانه. اذا عندي جي زائد واحد راح يكون عندي الزمن البعد، وبنفس الوقت اذا عندي تي للجي راح الزمن في نفس الوقت اللي راح الزمن في نفس الوقت الصفر اللي عندنا هنا. يعني عندنا في وقت مثلا الزمن الثانية اللي هي فرضا 2 ومثلا 3 بعدها ما جاي، احنا راح ناخذ 2 و3 يعني مال هسه وبعد زمن الجاي. اوكي
Okay. This is a explicit formula for the diffusion equation. We put R equal to K delta T over delta X2 because for each term at the right hand side we have this coefficient K delta T over delta X2 minus 2 1 minus 2 K delta T over delta X2 and again we have a K delta T over delta X2. We put this fraction is R and we have a simple equation for diffusion equation by using explicit method, and we have ui and j plus 1 is the unknown value is equal r ui minus 1 and j is none. 1 minus 2r ui and j is none plus r ui plus 1 and j. Again, this value is none, but ui and j plus 1 is unknown. This is the formulation for explicit method for a diffusion equation. Okay, and it's called two formula. Please attention. This diagram help you to understand this formula. For each point at the time level j plus 1, for example, I and j plus 1, we must use 3 points at the previous time step. Means I minus 1, I minus 1 and j for this point. For this point, we use the value of ui and j. And for the end point, we use I plus 1 and j. Based on 3 known value of the previous step size, we can compute the value of u at the newest step size. This is newest step size, and these red nodes are the old value of u or old step size. We can compute unknown value of u at the new time level j plus 1 directly from the value of u, value of previous time level means tj. They are not computed at the new time level, and the value at the new time level are dependent on the value at the previous time level. The process advancing from the initial condition. Okay, please attention. We start from initial condition and move on to the next step size or to the next time level. Before I go to the implicit method, I solve an example for you. Please let me to find an example. Okay, it's here. Example 1. At this example, we have a diffusion equation ut equal kuxx. This is diffusion equation. This equation is the is applied for heat conduction. At T equal 1, we can use explicit method and put delta T equal to 0.05, delta X equal 0.25, and K is 0.5. And we are going to obtain the solution of the following heat conduction equation at T equal 1 using explicit method, and we put delta T, delta X, and K based on in the example. The boundary condition and initial condition is here. Initial condition is U, X, and 0 for all of X, and in T0, that T0 is 0, is computed from X times 1 minus X. Okay, this is the initial condition. This is the initial condition, and for all of point at the initial condition, we use U, X, and 0, X in 1 minus X. At this time level, U, X, and 0 is used and equal to X times 1 minus X. And the boundary condition, for boundary conditions, we have for the left boundary, we have 0, and also for the right boundary, again, we have 0. The value of U at this boundary is U, 0, and T. For each T, for every T, we have the value of U is 0. And then for this boundary, we have U at 1 and T. Why 1? Because X starts from 0 until 2, 2, 2. U at 1 and T for every T is again 0. They are boundary condition, and this is a initial condition. Okay. The problem says you suppose that delta X equal to 0.25, and then we have x1 is 0, x2 equal 0.25, x3 equal to 0.5, x4 0.75, and x5 is the end of x and is 1. The problem says you put that delta t equals 0.05, and then we have t1 start point for t is 0, t2 is 0.05, t3 is 0.1, t4 is 0.15, and t5 is 0.2, and this construct of tj should be continued. Based on the initial condition, we have u1 and 1, means u at x1 and t1, x1 is 0 and t1 again is 0. And when we use the initial condition, we have for the initial condition the value of u compute from x times 1 minus x. Okay, and when we use this formula for u for initial condition at t1, we have the 0 for u1 and 1. Please attention. This is the first step. This is a start point for T1. T1 is 0. We are at the first step, okay? Initial step. And for this initial step, we have 5 points. This point, this point, this point, this point, and finally this point. For the first point, u1 and 1, For this point, u2 and 1. Next point, we have 3 and 1. For the next point, we have 4 and 1. And for the end point, we have u5 and 1. Okay? These points are here. We are going to compute the value of u in the initial step based on the initial condition. When we say u1 and 1 means ux1 and t1, u2 means ux2 and t1, u3 means ux3 and t1, u4 and 1 means ux4 and t1, u5 and 1 means ux5 and t1. For all of these points, we should use the formula x times 1 minus x. And when we use this formula for u, we have, for example, for ux2 and t1 means u at 0.25 and 0. This is x and this is t. And when we put in there x in 1 minus x, and the value of u21 is 0.1875. For u3 and 1 means u at 0.5 and 0, and we have 0.5 times 1 minus 0.5, and the result is 0.25. For the next point, for u4 and 1 means u at x4 and t1 equal to u. x4 is 0.75 and the t1 is also 0. And when we use x times 1 minus x, we have the value of u4 and 1, 0.1875. And for the endpoint at this row means u5 and 1, or u at x5 and t1, u1 and 0 is 1 times 1 minus 1, and the result is 0. And we have at this table, at the first row, you can see the value of I. I is 1, 2, 3, 4, and 5. For the second row, you can see the value of xi. x1 is 0, x2, x3, x4, and x5. And the third row, you have the value of u based on the initial condition, ui and 1. When we have I and 1 means the value of u at the initial step. ui and 1 means u at xi and t1 is 0. Based on the above computation, we have u1 and 1 is 0, u2 and 1 is 0.1875, u3 and 5 is 0.25, and also for another value of u for I equal to 4 and 5. Okay? بچه تا اینجا متوجه شدین؟ Did you understand?
Yes.
Okay. Continue. Based on the boundary condition, we have u, I, and u1 and j. When we have the index 1 for the u, means u at x1 and tj. x1 is the start point of x. X starts from x1 to xn. Okay, and x1 is 0. And when we have the 0 for x, based on the left boundary condition, we have the value is 0. And also u5 and j. u5 and j means u at x5 and tj. x5 is 1 and u at 1 and tj is for the point that they are on the right boundary. And for the point on the right boundary, we have the value of u is 0. Okay? And then from now, at this example, when we have u1 and j for every j, this is important that the index of x should be 1. When we have u1 and for every j, we put this value of u is 0. And also, for every u with the indexes 5 and j, for every j, we can use the 0 based on the right boundary conditions. Okay, we have for r equal to car delta t over delta x2. The problem says you can put k is 0.5, delta t is 0.05, delta x is 0.25, and this value should be powered 2. And for this problem, for this value of parameter and delta t and delta x, the explicit formula is, general form for explicit formula is ui and j plus 1 equal to ru I minus 1 and j plus 1 minus 2 ru I and j plus ru I plus 1 and j. And we put r is 0.4, and we have u and j plus 1 equal to 0.4 ui minus 1 and j plus 0.2 ui and j plus 0.4 ui plus 1 and j. And we move on. We move to the next time level. The next time level is T2. T1 is the initial time, and then we move to the next time level, means T2. The value of u at T1 is known, and the value of u at T2 is unknown. And we are going to move to the next time level, T2, means that T2 is equal 0.405, and we should put j equal 1. When we put j equal 1 at this formula, we have put j 1. We have ui and 2 equal 0.4 ui minus 1 and 1 plus 0.2 ui and 1 plus 0.4 ui minus 1 and 1. For what I equal 2, 3, and only for 3 points, because we have 3 interior points at each step size. Please attention. At each time step, we have 5 points, okay? And the first point and the last point are known because they are on the boundary and the value of u is 0. Then for every time step, we have only 3 interior points, and we should compute the value of u at these 3 interior points. And I for 3 points are 2, 3, and 4. بچه نگاه کنید، ما چون n مساوی با 5 هستش، تو هر گام زمانی 5 نقطه داریم. اولی و آخری که به کمک مقادیر مرزی به دست میاد. پس فقط تو هر گام زمانی ما باید 3 نقطه براش یو حساب کنیم. برای این 3 نقطه باید یو حساب کنیم. برای چه آی هایی؟ برای آی مساوی با 2، 3 و 4. خانم زینب شما متوجه شدیم؟
بله خانم، یعنی هم مثل درس دیروز بود دیگه.
تقریبا.
مرزی ها میشه 0، فقط داخلی ها رو حساب میکنیم، مثل اون نقطه مشکی ها. درسته.
فقط خانم رضا همیشه مرز صفر نیست. من برای شما تمرین میفرستم. ممکنه من مثلا روی مرز 80 باشه، روی مرز 100. تو مثلا دیروز دیدین که براتون اکسرسایز فرستادم، همیشه رو مرزا صفر نیست، ممکنه هر مقداری باشه. این حواستون باشه تو این مثال استثناء صفر. این لطفا توضیح بدید.
اوكي. هسه هنا شنو تقول لنا بما ان احنا راح نبدأ من نقطة الصفر، هو مطينا قيمة x من الصفر للواحد، وقسمنا طلع قيمة ال n مالتنا 5، قسمنا عليه من قيمة x راح يصير نحصل على 5. زين، راح يكون عندنا النقاط الحدودية اللي هي x11 يو لل11 ويو لل5 و1. بما ان بدينا من الصفر راح يكون عندنا اصفار اللي احتاجهن راح اطلعهن النقاط الداخلية اللي هي يو ل2 1 يو ل3 1 يو ل4 1، لأن ذن البداية والنهاية هن أصفار. أوكي، طبعا بس بهذا المثال فقط.
Okay, I will continue. Start from I equal 2, then I equal 3, and then I equal 4. When we have I equal 2, this formula change to, please attention, this is general form for this problem, and at this formula we put first I equal 2, and we have 0.4 u I minus 1 is 1 and 1, I and 1 is 2 and 1, I plus 1 and 1 is u 3 and 1. And we have these values based on the initial conditions. We have this value u1 and 1 is 0, u2 and 1 is 0.1875, and u3 and 1 is 0.25. When we compute this expression, the result is 0.1375. And we go to the I equal 3. U3 and 2 is 0.4 U2 and 1.2 U3 and 1 and 0.4 U4 and 1. And we put the value of this U at this formula, and then we have 0.24 I equal 3, and we have the value of U 3 and 2, or U at x3 and t2. And then we put I equal 4, and the value of U for this point is replaced, and the result is 0.1375. And when we compute 3U for this interior points, we have the value of U for T2. For at now, we have the value of U at T2. And the next row of this table could be complete. UI and 2 means U at XI and T2. And we replace this value that we have been computed at this table. Now, for the T1
قیمت تیار رو خودش بهمون میده یا یکی که خودمون در میاد؟
یعنی چه؟ خودمون گام زمانی داریم دیگه. دلتا تی رو گفته چقدر بگیرید، خود مسئله گفته دلتا تی رو، بذار مسئله رو بیارم، گفته with delta put delta t is 0.05. دلتا تی مسئله بهمون داده. خب تیامون هم از چند شروع میشه؟
که خودش از 1 شروع میشه.
از 3. بله. ایکس همون هم که نه، تیامون از 0 شروع میشه.
چرا؟
تیامون از ولیوش 0، ایندکسش 1.
تو سوال بهتون داده تی مساوی با 1.
نه، تی مساوی با یکمون 0. ببینید استارت فور تیمون 0. دیگه تی
یه لحظه برگردین، من اینو متوجهم. برگردین سر سوال نوشته ات تی مساوی با 1.
آره، ما تا تی مساوی با 1 باید بریم، باید بریم جلو
برسیم به بله. حالا متوجهم.
اینجوری است. از 0 میشه برای 500 1 دهم 15 صدم.
درسته. بله تا برسیم به 1
تا به 1 برسیم. اینجوریه. یعنی نمیتونی یک مرتبه بریم 1، باید با یه گام زمانی بریم جلو. مثل اینکه شما
اولش میگفتش که از اولش میگفت تی بین 0 و 1 دلتا تی مو میداد 5 صدم.
نه تی نمیتونه بگی بین 0 و 1. ممکنه تو مسئله بعد بگی تا تی 2 برو. تو دیفیوژن ها تی آزاده. مثل مسئله الیپتیک نیست که مثلا تی رو محدود کنه. یعنی ممکنه همین مسئله بعد تی کنیم هم حل بشه. خب چون ما که رو تی یکمون که باندری نداریم که از بالا آزاده. اوکی؟
بله.
پس نگاه کنید T1 مون یعنی اینیشیال تایممون چنده؟ 0. T1 یعنی فرست استپمون گام اولمون T1 که با 0 شروع میشه. همینجور شما ادامهش بدین تا برسیم بالاخره به حالا یه تی با یه اندیسی که چی بشه؟ مساوی با 1 بشه. اینجا استاپ میکنید. اینجا دیگه استاپ.
متوجه شدیم. متوجه شدم. ممنون.
خب تا کجا گفتیم؟ and okay and داشتم اینو میگفتم بچه. خب در T1 مساوی با at T1 equal to 0 we have the value of u based on initial condition and T2 the value of u at T2 they are in this table. They are the value of u at T2. Okay, and now we have the value of u at T1 and also we have the value of u at T2. And now we can go to the next time level and we are going to compute the value of u at the next time level. We are going to T3 and T3 is 0.1 because the step size is 40 is 0.05. Okay, and at this time we have not the value of u for T3 and we should use the explicit formula for computing the value of u at T3 and then we should put j equal to 2. When we put j equal to 2 we have this formula for the for the third line, for the third time level. And we should use this formula only for I equal to 3 and 5. For 2, 3 and 4. Only for 3 of I you should use this formula because for I is 1 and for I is 5 based on the boundary condition we have the value of u. And again, we put I equal to 2 and this formula change to u I minus 1 and 2 change to u 1 and 2, u I and 2 change to u2 and 2 and for u I plus 1 and 2 we have u3 and 2. At this table we have the value of u1 and 2, u2 and 2, and u3 and 2. For u1 and 2, we have 0. For u2 and 2, we have 0.1375. And for u3 and 2, 3 and 2 is here, and the value of u at this point is 0.2, and the result is 0, 1, 0, 7, and 5. And then we put I equal to 3, and the value of u at 3 is obtained. We need the value of u22, u32, and u42, and the value of this u are presented at this table. We replace this value of u and then we have the value of u3 and 3. And the similar way is used for I equal 4 and we can compute the u4 and 3. When we compute this formula for I2, 3, and 4, the value of u at t 3 is known and they are not unknown. They are changed to be known. And this table, you can see the value of u at the 3-step size. The first row for u is for t is 0. The second row for u is t is 0.05. And the third row for u is u at t equal to 0.1. And for an exercise, you should continue this process to t equal 1. I compute this step for you for 3-step size. You should this process to receive to t equal 1. من برای شما تا 1/10 حل کردم. 3 مرحله برای شما حل شد. تا 1/10 حل کردم. شما باید این پروسه رو ادامه بدید تا برسید به t مساوی با 1.
بله.
این لطفا بهشون بگین که بدون اكسرسايز 1 چی هستش.
تقول هاي التمرين الأول هو شنو؟ هي طلعتها تي لحد 1/10. هاي موجودة عندنا تي 1/3 يساوي تي يو للإكس 1/10. إيش قد التي 1/10؟ لازم نطلع بعد كم مرحلة إلى يعني تي 3 إلى أن نوصل التي يساوي 1 وعد نتوقف. الباقي علينا واجب.
Okay. Everybody, are you in the class? You are very silent. خیلی شما Are you in the class? All of them are silent. I hope you are in the class actually. خیلی ساکت هستین. امیدوارم واقعا سر کلاس حواستون باشه. Okay.
طبعا ما يطلع لي المعادلة زمن بالسالب. لازم نطلع اي طبعا اكو طبعا كل شيء اكيد. هاي شوفي بدها تكتب لك اياها. زوجي ايش قد هو 5%. واحد زوجي 1/10. زوجي 5%. كل شوية لازم الزوجين شوفي بدها تكتب لك اياها. 7%. 25 اي 25%. حيل. هاي كم واحد كم تي لازم احنا نطلع عزه. لا التي 5%.
خانم زینب خیلی کار باید انجام بدید. نگاه کنید تازه شما
دارم میگم آره دارم براتون توضیح میدم. میگم
تازه تی 7
تی به 1 برس. درسته.
حالا شما تا نیم حل کنید کافی.
آخه قیمت تیش خیلی کمه. 500 5/10 هم نیست.
حالا شما تا بذارین تی 8 میشه 35/100. تی 9 میشه 14. تا شما تا تی 11 برید کافیه. نمیخوام تا یک
طلعوا لي التي ل 11.
اوكي.
طلعوا تي ل 11 يعني 45%. تقول هواية يقول تعطوني الواحد كومة الجدول يصير طوله. فانتوا لل 11 كافي. لل 5%. 5/10. شوفي كم. شوفي اللي هنا أنا قالت. شوفي أشرت لنا.
Everybody, if you solve this problem until T11 is sufficient. It's okay. And I don't want to continue until 1 because the step size is very much, and I don't have from you to continue 1. نمیخوام تا 1 برین چون گامای زمانی زیاد میشه. شما 6 تا 8 گام دیگه برین کافیه. نمیخوام تا 1 برین. همون تا نیمم که برین کافیه. Okay. We are going to the next method. The next method is implicit method. Implicit method means روش ضمنی. You can go to the rest and come back to the class after 15 minutes. Please go to the rest and after 15 minutes go to the class. Please come back to class full energy. برین 15 دقیقه استراحت داشته باشیم، بعد پر انرژی برگردیم. میخوام یک روش دیگر رو بخونیم. روش مقدار کار میبره، یه استراحت خوب داشته باشیم برگردیم. صبر کنید حلاتون برام بفرستین. Please rearrange this equation that it's marked by star such that unknown value of u put on the left and null value of u put on the right. مرتبش بکنید. اونهایی که معلوم هستن سمت راست، مجهولا سمت چپ قرار بگیره. Which of them is known and which of them is unknown? U that the indexes of t is j plus 1 is unknown, and u with the indexes if j is known. Known, this is unknown, this is unknown, and this is unknown. Please rearrange and send to me your solution.
أساتذة سمعتوا؟ تريد من عندنا قانون نسوي لها المعالم بجهة والمجاهيل بجهة. أوكي؟ هسه تريدها تدزولها إياها. هو هذا نفسه العلامة السؤال اللي بيهن لازم بجهة إيه هو هذا، على هذا راح نحصل على قانون أتوقع. أوكي.
When you solve this problem, please and send to me. Please inform me. وقتی حل کردین بهم اطلاع بدین، واتساپ چک کنم. Thank you. Thank you. I check it. Two ui minus 1 and j plus 1 plus 2k delta t over delta x2 plus 1 ui and j plus 1, again it's unknown. All of them is unknown value. Minus k delta t over delta x2 ui plus 1 and j plus 1. This value of u is also unknown. And in the right side, you have only ui and j, and the value of ui and j is known. Ui minus 1 and j plus 1, ui and j plus 1, ui plus 1 and j plus 1, all of them are unknown value, but uij is only known value. Okay, please attention. At this diagram, you can see this formula better and clear. If you attention to this diagram, please listen, please let me to zoom out this page and clean my page. If you be careful, you can see at this formula we use 4 point. We use the 4 point. Okay. Three of this point is on the next level, next time level, and only one of them is in the current time level. If we are on the TJ, the value of u at TJ is none. But the next time step at TJ plus 1, it is the value of u at this time level is unknown. The red point is non-value, and the white points are the unknown value. And for point I and j plus 1, we need I minus 1 and j plus 1, I and j plus 1, I plus 1 and j plus 1, and I and j. You need 4 points. Okay. I have a question from you. Do you compute the value of u at tj plus 1 by using the value of tj؟ سالم اینه خانم زینب. آیا با همچین فرمولی که ما 3 تا نقطه از مجهولمون از تایم جدیدمون داریم، فقط یه نقطه از تایم قدیم داریم، میتونیم بیایم برای هر نقطه تک تک مقدار یو رو در گام زمانی جدید حساب کنیم؟ یعنی مثلا اگر بخوام بیام یو رو در آی جی به اضافه استفاده کنم، آیا میتونم فقط به کمک این فرمیشنی که در گام زمانی قبل دارم این یو رو حساب کنم یا خیر؟ یه بار سوال تکرار میکنم.
فکر کنم نه.
چی؟
فکر کنم نه. نمیشه
دیگه. چرا؟ چون به همسایه هاش هم نیاز داره. آفرین. چون به مقادیر در همسایه هاش هم نیاز داریم که اونها رو هم نداریم. پلیز اتنشن. این implicit in the explicit method here. In the explicit method, at the new time step, we have only 1 point at the time level j plus 1. At this 1 point, we can compute the u by using the value of u at 3 point at the old step size. تو روش سریع ما فقط یه نقطه داشتیم به کمک 3 نقطه زمان قدیم حساب میشد، یعنی همش معلوم بود. But in the implicit method, we need 3 point at the new step size. Means we need the value of I and j plus 1 and I minus 1 j plus 1 and I plus 1 and j plus 1. And all of them is unknown. Then we cannot compute for each point at tj plus 1 directly. Okay? The discussion is here. We can no longer explicitly solve for each unknown value independently, but must solve for unknown as a set of linear equations. When we write this formula, this implicit formula, for each point, then finally we have a system of linear equations. We should write one equation for each unknown value. When we write this equation, finally we have a system of linear equations. Pay attention. Suppose we are computing the value of u for j equal to, okay? For all interior point at this time level, I write the implicit formula. I from I equal 2 to I equal n minus 1. For all of the interior point, only for j equal 2, not for the next time level. For only j equal 2, we write the implicit formula, and finally we have a system of equation. At this figure, you can see the red point are the known value. They are initial value, and they are boundary value. They are boundary value. The red points are known, and the white points are unknown value. If we put our such a explicit method, when we put r equal to k delta t over delta x2, we have minus r u I minus 1 and j plus 1 plus 1 plus 2r u I and j plus 1 minus r u I plus 1 and j plus 1 equal u I and j. Please attention. The weight means the weight of point are the flow, please. One point, and finally point. I minus 1 and j plus 1. I and j plus 1. And I plus 1 and j plus 1, okay? And the point at the old time level is I and j. The weight for this point is minus r. The weight for this point again is minus r, and the weight for this point is 1 plus 2r, and the weight for this point is 1. We use this diagram for apply the implicit formula for all of j, and for each j for I equal to 3 to n minus 1. We are going to write this formula. First, we put j equal 1. So we have j is 1, and we write the fourth formula for I equal to 3 to n minus 1. When we put I equal to based on 4, we have minus r u 1 and 2 plus 1 plus 2r u 2 minus r u 3 and 2 equal u 2 and 1. Based on 4, I write this formula for j equal 1 and I equal 2. The red term is boundary condition, and this red term, and we have the value of u. u1 and 2 is the boundary condition, and the value of this point is known. u22 is the value of u at the old time level, and again the value of this u is known. We put the unknown terms left side and move the known values to right side, and we have 1 plus 2r u22 minus r u3 and 2 equal u2 and 1 plus r u1 and 2. For the next, we use this fourth formula. Again, j is 1 and I is 3. We move to the right point. We are in j plus. We are in T2 and move from every point to the next point. I is 2, I is 3, I is 4, until 2, I is n minus 1. For I equal 3, based on 4, we have minus r u22 plus 1 plus 2r u32 minus r u42 equal to u3 and 1. The red u are now. We have the value of u3 and 1 because this u belong to the older time level, and we have the value of u at the old time level. Then we put again j is 1, but I is 4, and we have minus ru3 and 2 plus I1 plus 2 ru4 and 2 minus u5 and 2 equal u4 and 1. And for when we receive 2i in generally, we have minus ru I minus 1 and 2. 1 plus 2 ru I and 2 because j is 1. Minus r u I plus 1 and 2 equal u I and 1, and u I and 1 is now. And when we receive 2i equal n minus 1, we have minus r u n minus 2 and 2 plus 1 plus 2 ru n minus 1 and 2 من های r minus r u n and 2. un and 2 is the boundary value, and the value of this point is known, equal to un minus 1 and 1. When we move the known value to the right, we have the finally expression. Okay. I want at this page we have n-2 linear equation. Why n-2? Why n-2? Why not n? چرا n منهای 2 تا معادله می نویسیم؟ چرا n تا معادله ننوشتیم؟
چون خانم باقل از دو طرف ماینس آر داریم، درسته؟
اوکی بسیار عالی. چون دو تا نقطه اول و آخر میرن کنار، چون مقادیرشون رو داریم، نان هستن، درسته؟ پس فقط n منهای 2 نقطه آن نان داریم که میه براشون در واقع معادله می نویسیم. خب الان از شما یه سوال دارم. تو این صفحه شما یک سری معادله میبینید. میخوام این معادلاتی که میبینید رو به صورت یک سیستم معادلات خطی برام بازنویسی کنید. دقت کنید چی میگم؟ یک سیستم معادله خطی برام بنویسید. به حلاتون برام بفرستید همین الان. یعنی میخوام به شکل ماتریکسی نماید. از شما ماتریکس پرزنتیشن میخوام.
اوکی بزرگم ببخشم.
I want from you to change these equations to the linear equation, to a system of linear equation as a IU equal to B. We need the matrix presentation. حالا براشون توضیح بدم.
أساتذة عندنا هذين الستة المعادلات الخطية اللي قبالكم، هذين المعادلات أريد أسويهم حسب معادلات خطية. شلون ذني سويناهن؟ بس ما أريد معادلات خطية، تريدين حسب شلون المصفوفات اللي سويناهن، المعالم الجهة والمجاهيل الجهة، مو المعالم. إذن المعالم نسويها مصفوفات، أوكي؟ اللي ما بعد المساواة هم نسويها مصفوفات، أوكي؟ والمجاهيل تصير مصفوفة شلون كانت مال -4، أوكي؟ حلو. هسه إيه.
مثلا یه توضیح بدم خانم زینب. مثلا میگیم دستگاه 3 معادله 3 مجهول داریم، درسته؟ 3 تا معادله داریم، شما یه ماتریس ضرایب پیدا میکنید، یه بردار مجهول پیدا میکنید، یه مقادیر معلوم که میره سمت راست میشینه. خب یعنی معادلات به شکل ماتریسی مینویسید. حالا همین از شما میخوام. ما چیا رو نداریم الان؟ مجهول ما چیا هستن؟ U22 U32 U42 U52 until n-1 and 2. Please attention, everybody. At this equation, the unknown value is not first point, is the point I2 and k plus 1, this is 2. 2 and 2 is unknown. The U at 3 and 2 is unknown. The U at U4 and 2 is unknown. And finally, the value of U at n-1 and 2 is unknown. But the UN and 2 is known. Okay? You make the vector of unknown and change these equations to AU equal B. I want from you matrix presentation of these equations. I wait for your solution. Everybody, please solve this exercise. as a coordinates, the vector of unknown is u2 and 2, u3 and 2, 4 and 2, and it's continue to u and minus 1 and 2. Okay? Based on this unknown vector, you write the coefficient matrix and also the non-vector at the right. Please complete this matrix and this vector.
باقي براتون فرستادین درسته؟
I will check. پلیز خط 2 رو سطر 2 ماتریس کاملش کنید. همینطور سطر 3 یعنی سه حالت نیست. بقیه‌اش چنده وقتی سطر اول رو داریم؟ بقیه‌اش چنده؟ 0 دیگه. یعنی شما از اون NMN های دوتا تو سطر اول، خانم زینب دقت کنید، تو سطر اول وقتی سطر اول می نویسید بقیه‌اش چند ضریب هاشون؟ 0. درسته؟ سطر دوم که می نویسید ستای اولش غیر 0، بقیه‌اش چی میشه؟ 0. فقط بی‌دقتی کردین توی سطر سوم. ما 1 نداریم اصلا تو ضرایبمون.
درسته، 0.
0 هم نیست. دقت کنید. اولی 0، بعدی منفی آره، بعدی 1 به اضافه 2 آره، بعدی دوباره منهای آره، بعد دیگه بقیه‌اش 0. یه ماتریس 3 قطری داریم. چکش کنید از اول.
اوکی، یه لحظه.
Coefficient of u22 is 1 plus 2r, and then write 1 plus 2r. Next, we need the coefficient of u3 and 2. The coefficient of u3 and 2 is minus r, and we write minus r. We need the coefficient of u4 and 1. We don't have u4 and u4 and 2. We don't have u4 and 2 in this equation, and the coefficient is 0. The next is the coefficient of u5 and 2. And in the first equation, I don't have the u5 and 2, and the coefficient of this u is 0. And it is continue, and finally the coefficient of u n minus 1 and 2 at the first equation is 0. And write 0 for the coefficient of u n minus 1 and 2. Okay, for the first equation, I write the coefficient of element of unknown vectors. برای معادله اول، سطر اول برای معادله اوله، سطر دوم برای معادله دوم، سطر سوم برای معادله سوم. میام تو هر معادله ضریب‌هاش در سطر خودش می‌نویسم. Attention. The first row is for first equation. The second row is for second equation. The third row is for third equation. And at each row, we write the coefficient of an element of unknown vectors. Okay? We go to the second equation, this equation. At this equation, the coefficient of u2 and 2 is minus r. And I write minus r. The coefficient of u3 and 2, u3 and 2 in the second equation is 1 plus 2r. And write 1 plus 2r. And the coefficient of u4 and 2 here, u4 and 2 is minus r, and write minus r. And for the rest u, the coefficient is 0, and I should write 0 for the rest of this row. We go to the third equation. This is third equation. At the third equation, the coefficient of u2 and 2 is 0, because at this equation we don't have the u2 and 2, and the coefficient is 0. The coefficient of u3 and 2 at this equation is minus r, and I write minus r. The coefficient of u4 and 2, u4 and 2, the coefficient is 1 plus 2r. And the coefficient of u5 and 2, it is minus r, not minus 1, is minus r. And for the rest of this row is 0. Is it okay? Did you understand?
Yes.
Miss Sima? Okay. And this process is continuous. Okay, finally, for the last equation, please attention. For the last equation, the coefficient of u2, 2 is 0, 3 is 0, 4 is 0. Only for the two last element, the coefficient is are not 0. For un minus 2 and 2, we have minus r. And for un minus 1 and 2, we have 1 plus 2r. And the coefficient matrix is present, okay? And what about the non-vector? The right value of each equation make the non-value non-vector of the matrix presentation. You can see all of them at this page. A non-vector, as we said to you, a non-vector is u2, 2, 3, 2 until u and minus 1 and 2. It is here. And the coefficient matrix has the general form 1 plus 2r minus r, and this matrix has 3 diameter, minus r minus r minus r minus r, again minus r minus r minus r, and minus r. And the right side we have u2 and 1, it's none. u3 and 1, it's none. u4 and 9, the 1, it's none. and finally u n minus 1 and 1 is none. If you be careful, you see that for the first equation and for the last equation, in addition, the value of u at the time level t, we have the value of the point at the boundary point. For the first equation, in addition of u2 and 1, we have ru1 and 2. And for the last equation, in addition of un minus 1 and 1, we have run and 1. And for the interior, we don't have this there. And we have the extra vector for the first equation and for the last equation. Finally, we can write this matrix as the closed form. RU2 equal to U1 plus U1 plus, excuse me, I should correct, RU2 equal to U1 plus C2. This U is extra. This is the matrix form at the closed form, okay? When the system is solved, this is a system linear equation. When the system is solved, the value of u are obtained at all interpoint at once. دقیقاً چی میگم بچه‌ها؟ تو روش اکسپلیسیت چیکار میکردیم؟ دونه دونه همه رو حساب میکردیم. ولی اینجا یک مرتبه همه مقادیر یو در گام زمانی j به اضافه 1 به دست میاد. یک دونه دونه حساب نمیشه. At explicit method, we solve one by one value of the new time level, and in the implicit method, we compute the value of u for all of the interior points at once. Okay? خانم زینب دونه دونه اینجا یک مرتبه همه به دستش میاریم.
بله. بگم خانم باقری؟
لطف میکنید.
تقول بديك الطريقة قبل ذاك اللي أخذناها، ذاك كنا ناخذ نقطة نقطة وحدة نطبقهن ونطلع الليوات مالتهن. بس بهاي الطريقة، طريقة الماتريس اللي هسه هنا طلعناهن، نطلعهن كلهن بصورة عامة، كلهن نطلعهن بقانون واحد، ما نطلع وحدة الناتج مالتهن. أوكي؟
Not for j equal 1, but for every j is 2, 3, and so on. We have a system of linear equations such as above and must be solved. In general, for each j we have, the matrix for every j is constant. This matrix don't change for every j. This is a constant fixed. This matrix is fixed for every time level. But when we go to the new time level, the indexes is j plus 1. J plus 1 means the new time level. And the format of the right side is fixed, but the indexes is j, this is uj, and this value of the second vector return to the boundary value at new time level, and we called is cj plus 1. Why j plus 1? Because u1 and j plus 1 and un and j plus 1, they are the boundary points at the new time level, and the value of this point are known. Okay? So it's sufficient for solve the diffusion equation by the implicit method. we should use this matrix presentation. Okay. برای حل یک معادله دیفیوژن از طریق روش ضمنی همین روش ماتریسی به کار بگیریم کافیه. یعنی با نمایش ماتریسی حلش کنیم کافیه. ماتریس هم فیکسه. یعنی شما روش که حالا مقادیر که عوض بشه، حالا معادله که عوض بشه، این ثابته. فقط آرش تغییر میکنه. این R change, but the format of this matrix is fixed. Okay? Is it okay? Did you understand? Okay. We are going to solve an example. Okay. I don't have to talk about Crank-Nicolson method. And Crank-Nicolson method will be for next session. Okay, example. Please attention. At this example, we have obtain the solution of the following heat conduction at T equal 0.5. Using implicit method, put delta T equal 0.1 and again delta X is 0.25. The equation is UT equal UXX. What is the value of K? What is the value of K at this example? At the previous example, the value of K is clear. But at this example, we should obtain the value of K based on the equation. K is the coefficient of UXX. At this example, the coefficient of UXX is 1. And so, the value of K is 1. Is it clear for you? ضریب K تو معادله قبلی خودش بهمون داده بود. ولی تو این معادله بهمون نداده. اینجا خودمون بایستی از رو معادله متوجه بشیم که K چنده. K ضریب UXX که اینجا 1. پس این example K is equal 1. اوکی؟
بزنگم خانم باقر.
متوجه شدین خودتون خانم زینب؟
بله.
لطفا بهشون
يقول التي بذاك السؤال هو كان مطينا اياها اتوقع 15 بود نه؟ هم تو مثال قبلی 15 بود.
نه تو مثال قبلیه
14 بود.
بله 15 بود. اوکی. میگه در C at this example K is نیم. K is نیم.
شوف هنا هسه شوف اي المشتقة الثانية. هنا ما مطينا اياها، بما ان ما مطينا اياها لازم انا اطلعها. اذا هنا معامل المشتقة الثانية للاكسية عفي 1.
Okay. And we have delta x 0.25 and then n is equal 5. x1 0, x2 0.25, x3 and x4, and finally x5 is 1. Delta t at this example it is not 0.05, is 0.1. It's 0.1. And then T1 is 0, T2 0.1, T3 0.2, 0.3, and this continue. It should be correct. And you should be continued this by this step size until we receive to delta T, receive to T is 0.5. Again, based on the initial condition, we have the value of U with the indexes I and 1. When we have 1 for the second index, it's referred to the initial condition, and based such as the last previous example, we have continued the value of U at the first step size. And the value of U, I and 1 means U at X, I and 0 because T1 is 0. T1 is 0. And the value of u at this time level are in this table. And also, as a previous example, u1 and j and u5 and j for j equal 1, 2, 3, and so on is 0 based on the boundary condition. Okay? And at now, we are going to compute the value of r. R equal k delta t over delta x2. K at this example is 1, delta t is 0.1, and delta x is again 0.25. And the result is 1.6 for r. For the implicit formula, we have minus r u I minus 1 j plus 1, 1 plus 2r u I j plus 1 minus r u I plus 1 j plus 1 equal to u I and j. And we have this matrix presentation. Please attention. When you write this formula for example, j equal 1 and then 2 and then 3, but for I equal 2, we have 5 point for I. First, and n is for boundary, and we should write this formula only for I is 2, 3, and 4. If you careful, the indexes of the matrix, please let me to go to implicit method. Please attention. At this formula, at this matrix representation, the dimension of the matrix is n minus 2 and n minus 2. Okay? When the matrix, when the n at our example is equal 5, then n minus 2 is 3, and the dimension of this matrix is 3 by 3. Okay? And we have only this part of this matrix, only 3 by 3 matrix. Okay? Because at our example, n equal 5, then n minus 2 is 3, and we have the 3 by 3 coefficient matrix, and only we need the this part of this matrix. And for the unknown vector, we need this part of vector. For the non-vector, at the right side, we need 3 part. And for this boundary vector, we need first and end and a 0 between them. And we have this matrix presentation. Attention. 1 plus 2r minus r and 0. The second row minus r, 1 plus 2r minus r. Third row 0 minus r and 1 plus 2r. And the dimension of this matrix is 3 by 3. The unknown vector is u2 and j plus 1, u3 and u4 j plus 1. It is a vector by dimension 3. The non-vector is u2 and j. This is the old time level, and the value of this u is none. Then u3 and j, then u4 and j. And the boundary vector for the first is r, u1 and j plus 1. It is the point at the left boundary. And r, u5 and j plus 1, it's the point at the right boundary. And it's sufficient to Replace the value of 1 plus 2r and minus 1. If we replace the value of this 1 plus 2r and minus r, we have the 1.6 for r. And we replace 1.6 for r. And we have this coefficient matrix. This is unknown vector, this is non-vector, and this boundary vector, because the value of u at the boundary is 0, these are the 0 vector, and it can be removed. Okay, and we have this matrix equation for every j. For j is 1, 2, 3, and so on. This is the matrix presentation for this problem. Let's start with j equal 1. We put j is 1. This matrix is fixed, don't change. And when we put j is 1, we have u22, u32, and u22. All of the unknown interior u of interior point. U2 and J, 3 and J, 4 and J change to U2 and 1, 3 and 1, 4 and 1. And this value are known based on the initial condition. At the table, we are this value based on the initial condition. It is a system of linear condition, and you should solve this system, and you can compute the value of the interior point of u and of the interior point for the next time level, means for u at 1.5. Okay, and we put this value in the table. u1 and 2 is boundary, is 0, 5 and 2 is 0 is boundary, and these three values are replaced for interior point 2 and 2, 3 and 2, and finally 4 and 2. And then we have the value at j at the time level nu, means that T3 and T2 is 0.1. So خب تا اینجا یاد گرفت بچه؟ دیدی understand؟ براتون اوکی هست؟
Yes, yes, yes.
Move to the next time level, T3 and T3 equal 0.2, and we should put J equal 2. But again, this matrix is constant, is fixed, and don't change. And the unknown value is changed because we are going to T3, and the indexes of J is 3 for unknown value. But the right side is the known value, and we should put ui and 2. ui and 2 at the last level are computed. 2 and 2, 3 and 2, and 4 and 2 are computed. When we solve this system of equation, we have the value of u at u3. This should be correct. u2 and 3, 3 and 3, and 4 and 3. This value are known, and we have the value for all of interior point at T3 at once. یک مرده تونستیم همه جواب ها رو برای سطر سوم به دست بیاریم for T3. And then we put this value at the third row of the table. Okay? As an example, you should continue the process until 2.5. You should only 3 level time for T4, T5, and T6. Please solve T3 at now. Please T4. Please solve this example for T4 at now. این مثال حالا شما مقادیر تی رو، مقادیر یو رو در گام زمانی سوم دارید. حالا بریم برای گام زمانی چهارم حسابش کنید. بعد حلاتون برام بفرستید. Please solve this problem for T4 by using the implicit method and send for me your solution.
الو کام بقری
بله منتظر هستم. The matrix is fixed. ماتریکس تغییر نمیکنه، فقط بردار مجهول ها اندیسه 4 میگیره. بردار معلوم ها باید بردار مقادیره که الان به دست در گام زمانی قبل دست آوردین رو بذارید. ببینم چیکار میکنید. برام بنویسین، یعنی مجهول و معلوم برام جداگانه بنویسید که چیا معلومه چیا مجهوله. Let me fill in this page. Missimo, this matrix representation at the top of the page is general for this problem, not for every problem. For this example, it is the general form. You should apply this matrix representation for every J. For example, at first we put J is 1, okay? When we put J is 1, this matrix don't change, it's fixed, okay? And write this matrix. Why? Because of I put J is 1, this matrix, this vector is U2 and 2, U3 and 2, U4 and 2, okay? This vector refer to this. And U2 to when we put J1, this vector is U2 and 1, U3 and 1, and U4 and 1, okay? This value are in the T1 and the value of this point are known because of initial condition. این مقادیر رو ما به کمک شرط اولیه‌مون داریم. تیبلش رو نگاه کنید. At this table you can see U2 and 2 is 0.1875, U3 and 1 we have the value, and for U4 and 1 we have the value. They are computed based on the initial condition, okay? Based on the initial condition, I have this value. And for U1, U2 and 1, we put the value is 0.1875. For U3 and 1, we have the value is 0.215. For U4 and 1, we have the value and is 0.1875. And you can solve this system by every method. For example, Gauss elimination. For example, by A inverse at B. Please attention. If you suppose this matrix form is AU equal B, you can solve this system by any way. For example, U equal to A inverse by B, okay? Or you can see, for example, Gauss elimination for solve this matrix equation, okay? شما میتونید به خانم زینب دقت چی میگم؟ این یک دستگاه هست دیگه، یک دستگاه 3×3. میتونید به هر روشی که خواستین حلش کنید. از راه اینورس میشه، از روش حذفی گاوس میشه، از هر روشی که بلد بوده این دستگاه رو حلش کنید دیگه. میتونید در واقع حالا به هر روشی که بلد هستین دستگاه رو حلش کنید. Missimo, Do you understand until now? تا اینجا یاد گرفتین؟ Okay. When we compute this value, now you have the value of u at T2. T1 is known because initial condition. You compute T2, okay? And now we are going to T3. Okay. You should again use this general form. You should again this general form. But you should put j is 2 because you are going to the next time level. And this time you put j is 2. Okay. And we have this matrix is constant. We have u 2 and 3, 3 and 3, and 4 and 3. And this value is the value that you compute at the previous time level. This value you should put for the noun vector. The value, the interior point at the next time, at the old time level, you should put for the noun vector. اون مقادیریویی که شما در گام زمانی قبلی حساب کردین و باید به عنوان بردار مقادیر معلوم بذارید. Okay. You should again have a system of equation and you can solve it by any method. Miss Zainab, Miss Sima, have you understand?
Yes.
Okay. من براتون این فایل میفرستم، خودتون مطالعه داشته باشید.
اوکی می‌خواستم همینو بهتون بگم، برام بفرستین فایلش رو.
بعد ادامه بدین خودتون. روش کرنگ نیکلسون هم هست که دیگه حالا پنجشنبه دیگه روش کرنگ نیکلسون رو بهتون میگم. چند تاپیک هم براتون مشخص میکنم، میفرستم به مطالعه کنید که برای درس بعد بیاد ارائه داشته باشید که نمره ارائه براتون در نظر.
اوکی.
Do you have any question? اگر سوالی هست بپرسید. Do you have any question? Yes or no?
نه ممنون، مرسی خانم باقری.
خواهش میکنم. Okay. We can finish the class and I hope you have a nice time. امیدوارم وقت خوبی داشته باشین، هفته خوبی داشته باشید and goodbye.
Goodbye.